Ooh, y'all didn't know I had that. Y'all didn't know I had that. Quit lying. Shit. What's going on, guys? Pardon that outburst. This is episode 20. Jared, where we at? 24 of the Swift and SwiftUI Learnalong. I am your host. The one with the most. The one that makes toast. But I don't like to boast. And I don't like to roast. So let's just get to the main thing. No, in all seriousness, though, yesterday we were not here. But we back today. As I've told you before, now and then I'll drop off if I have something to do, and I kind of woke up late, and then I talked to the whatever. None of that shit matters. The point is, I also have an interview today at 3 o'clock, which is a little under 2 hours my time from this point. So we're gonna move a little quickly. It's gonna be a short sesh, brother. But yeah, wish me luck, or wish me skill, wish me poise. It ain't got nothing to do with luck, right? But it's with JPMC, JP Morgan Chase. Might have heard about him a little bit. Big ass bank, you know. I'm working for them. So it's for a DevOps position. I did already secure another job, so these are the best interviews, honestly. I mean, I accepted it knowing I already had the other job because, I mean, A, you just never know, and B, it's good practice. So I can't promise that I'll remember, but I'm going to try my very best to record the interview because it's remote, it's on Zoom, and I just think it'd be cool to pick it apart on the stream, after the fact. Not today, but tomorrow or some other time. So yeah, I will try to remember to do that, but that's why we're gonna have a short sesh today. Okay. All right, now let's just get back into. Well, actually, Jay, brother, you set that. Give me an hour. Yeah, no, that. Well, I'll do it here. Okay, never mind. I'll do it here on the iPad. Yeah. All right, that's fine. Okay. Where were we yesterday, or the day before yesterday? We are youth of the nation. Okay, sorry. Now that I'll get on task. All right. All right. Is this really where we stopped? I recall it being, imagine that blah 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 victim pool. I thought we did do all this. Chapter 21. The warning in your... Okay, we did. I do remember this page, so... therefore... I've had a mic stand before. I hated that. It's all wobbly and shit. It's like poking in from the side. And it paused. But, just... It's all very annoying, Everything has a downside. I can't really lean into this thing because it'll pull my beard hair. But I don't like the gain being too high because then it's fuzzy. Blase, blah. Okay, this is where we were, so let's get started. 3, 2, 1, focus. Okay. Property observers. Swift provides an interesting feature called property observation. Property observers watch for and respond to changes in a given property. Property observation is available to any stored property that you define and is also available to any property that you inherit. Let's read that again. Let's read that again, brother. Property observers watch for and respond to changes in a given property, which, as we learned, what is a property exactly? Well, property is within the scope of a, like, here's a class, right? Or not. This whole thing is a class monster. And why isn't it highlighting for me? Yeah, whatever. This whole class, right? And so these variables, even the one with a closure in it, would be properties of this class. And the same would be true if this were a struct, we saw that, yeah, and also, what was the other one? And an enum. So in any case, these would be properties of said entity. Okay, so that's what we're talking about. So now let's read it again. Property observers watch for and respond to changes in a given property. So, yeah, they're like your, what you call them? Or they function like signals. They probably, it already seems like they're a bit more than that, but this is a way that we could do some kind of reactive programming. Like if this changes, then anything that derives its value from the thing we changed should also update themselves, or it should trigger, other code that we've written to then recalculate or reevaluate itself based off the change. You got it. We understand this. So then you cannot use property observers with computed properties that you define. Okay, then forget everything I just said. We can't use it for... You cannot use property observers with computed properties that you define. Okay, so this we couldn't use it with, because that's exactly what that was. Okay. Yeah. All right. But you have full control over the definition. Of a computed properties setter and getter, and can respond to changes there. I see. Yeah. I do remember looking at the get and set, the explicit get specifically, and the set, which is very handy, very literal in terms of what it's telling you that it's doing, which I like a lot. Like this is literally setting the value for this named parameter here, right? Or this is saying like literally go and get whatever this evaluates to. Very straightforward, and I very much like this. I was very pleased with this. And so that's what it's referring to. And so they're just saying we could still do it, we would just handle it here as opposed to some kind of top level handling like with these normal properties, non-computed properties. Wow, a lot of this stuff's sticking in my brain now. Okay, cool. So imagine that the citizens of your man, I am jacked, bro, on fucking Starbucks. I'm sorry, I can't keep still. It's just like busting out of me. I can't help it. Even if, like, I'm not necessarily nervous about the interview. Like I said, these are the best kind because, like, you already got a job. You don't have to sweat it so much. But obviously, I care. And it's J.P. Morgan Chase. Like, I don't know. I'm not like starstruck. They're just people. But it's, in a weird way, this is probably going to sound like a weird thing to say. But I've realized that as I've gotten older, now I'm in my, I don't want to age myself for nothing, brother, but I'm in my early 30s now. And so, yeah, emphasis on early, all right? But, now that I'm in my early 30s, I find that I'm no longer, I was never really struck by celebrities like, oh my God, I want to go see so-and-so. I'm like, why would I want to go see them? I can see them on the screen. Like that, concerts or book signings, like shit like that was never a big appeal, but make no mistake, I still had my fandoms, right? Yeah, still had plenty of celebrities I was a fan of and still do. However, as I've aged, I've realized I've come to like the real things that I admire. I guess that's really what it is. Like, what do you actually admire? And I know a lot of people legitimately admire celebrities for whatever attributes they have or we perceive them to possess, whatever, however you want to look at it. But for me, I started to admire like brands and not for like materialism, like not necessarily just because they're successful, but just for certain elements of their operation, or just things that you hear about, this is how they do things. This is how their internal technology works. This is a decision they made with their engineering department. Stuff like that. Because when you're in and around the biz, you talk about these things, because I've always worked for smaller companies. And it's always interesting because on the one hand, most of what you hear about when you hear about innovation in the technology space, they're always looking for people, or, well, how should I say this? If you look at like Y Combinator, just as an example, not saying they're the end all be all, but if you look at the kinds of ideas that are coming out of there, they're not radical, but they're different. A lot of these microservices that focus, kind of going back to the whole POSIX kind of philosophy in a weird way, coming full circle, but now it's like more apps that focus on just doing one thing really well. That's how you end up with, like, if you have a web app and now you're making external calls to like 15 different APIs, so there's a downside to everything. But my point in saying that is, generally speaking, you're told to be more free thinking, creative. We need new ideas. We need this, we need that. But you kind of don't, that's not encouraged when you're actually in industry. So it's a very backwards kind of mentality. And the reason that it's weird is that when you're working for smaller companies, I think in a way, just because of the resource constraint, they're a lot more risk averse. And so I hear a lot of people say, like, work for a small company, you can have bigger impact, blah, blah, blah. And that's true to an extent, but it depends on how small. It really depends on whether or not the internal, I'm assuming there's some kind of software product. That's what we're talking about. If it's not too mature yet, that might be true. If it's already matured, they have a user base, that really is not likely not the space where you would want to go. You're likely going to end up you're going to be maintaining their old apps. If anything, you might want to go, like, as a freelancer, you probably get access to those. Like, maybe the small company is willing to invest $50,000 into getting an MVP built for something like that, but generally probably not in-house, even, just because small companies just, they overcompensate all over the place. That's really the pattern that I've seen over the course of a decade. They just everything is an overcompensation. And it's disingenuous to say that, they're just fucking up, they're making wrong decisions, because I can't say that I would have necessarily known any better. And it's hard to quantify the value of decision making without some amount of time to observe what you did and how it impacted things. So there's a very after the fact kind of nature to the consequence of these decisions. And so oftentimes maybe the feedback loop protects people that, maybe made bad decisions. Just kind of depends on how you look at it, how you feel about it, right? Anyway, I say all that to say that I don't know what to expect. I mean, I really don't know what to expect, because I just think it's very, like, all of that kind of mashes up in my brain, and then I think, because the position is it's a DevOps position, working similar to what I was doing right before I left the old company, building microservices. That's what it sounds like. DevOps, data transformations, move this blob of data over there, make it look like this. It starts like this, make it look like this, and then send it to all these places. It's kind of all the same thing. It's just interesting to think of what Chase is doing in that way. I mean, obviously they have, but it's interesting too, because when I think of our banking systems and all that shit, just in my mind, I know this is not correct, but in my mind, I guess you kind of blame the media, but I just think that it's these ancient code bases written in Pascal and or maybe just straight up C, you know, and you know, because you always hear about how we have this, like which one is very it's pretty popular, the one written in the airline systems, you know, like that system they all use to check. I don't know if you ever seen their screens when they're typing in, but it's like that old school DOS style when they're looking for flights. If you like go to your gate, you're waiting to board. Those people, when you go up to the desk, talk to them. Like when you're in the reserve queue or whatever it's called. But anyway, I know that's written. A big part of that is written in COBOL. There was a pretty interesting documentary on it. But yeah, that's what I imagined. So I'm like, what are they? I just think it's weird to be interacting with. It's just different when it's a bank, you know? Like, I would definitely sweat just a little bit more knowing that I'm working with that kind of data. So on the one hand, there's like there's a hint of prestige to it, and I would take pride in that. Like, yeah, I work for Chase, you know, no big deal. But then again, it's like, well, the base work, like we know as programmers, it's not magic, right? It's still just programs, regardless of what language it's written in. It's still a bunch of data types, exchanging values and making sure it's the right data type. That's like most of what programming is. But yeah, I don't know. Anyway, I'm wasting part of this hour, but I'm trying to get in the right mindset and get it. Thanks, babe. You're the best. Okay, anyway, let's get back to this. Okay. Imagine that you're Oh yeah, okay. So we can't use it in the normal sense, but we can use the getter and setter to set it. Imagine the citizens of your beleaguered town demand that the mayor do something to protect them from the monsters terrorizing them. The mayor's first action is to track the attacks on the townspeople. Property observers are perfect for this task. You can observe changes to a property in one of two ways. When a property is about to change via will set, you can observe changes to a property in one of two ways. When a property is about to change, I hate this motherfucking Kindle app. Excuse me, pardon me. Okay. I need to spend some time and just convert my books to HTML and just be done with this bullshit. I'm so sick of this fucking app. All right. When a property is about to change via will set, we have. Oh, we've seen set. Okay, we have not seen will set. So I guess that's a new thing coming. And then when a property did change via did set. That's cool. So that's interesting. So you can choose, and I can see how that might matter. So do you want to change? You can observe changes to a property in one of two ways. That's really interesting. So will set, so you can preempt the change to a property, like change some other value before the inbound change to the property you are observing. Okay, I can see how that would make a lot of sense for some kind of like a ticketing system where no matter what, maybe you always want the new inbound value. Like if it's a portal where customers submit issues they're having with your software, and you just let them submit them, at will. They can just go to the portal, go to your website. It would make sense that if let's say you get the request, you read it, nothing's nil, everything looks good, and then using a Swift protocol, you could say, okay, but before I let you in, brother, new data, before I let you in, I need to use will set, and then take that ever increasing ticket number, because it just needs to be a unique ID, and then increment that up by 1, then receive the blob, the header, the summary, the body, would tell us what's going on, what version. Okay, yeah, okay, that's cool. That's cool. Yeah. I'm sure there's probably a way to do that with signals, but just since that's been my reference point, I don't know of one. Those would always be like kind of a waterfall change where you would just change, up at the top, change whatever value it is, then everything that reacts to it, boop, 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 would all just kind of react. But ahead of it, that's interesting. But cool. When a property did change via did set. Okay, to keep track of monster attacks, the mayor decides to pay close attention to when the population of the town changes. That's a good thought. Use a did set observer in Town Swift to be notified right after the property receives a new value. To be notified. That makes sense. A did set after the fact. Post event. Really? So var, I need to be in town. 54. Okay, you want me here, brother? 5422. Oh no. Oh, so interesting. So we're using the, what they call this, trailing syntax closure here. And this is a did set, so did set. Keyword did set. Old population. Man. Print the population has changed to population. To population from escape character or string interpolation. From old population. So did set. Okay. So we take the value of population, in this case 5,422. It would run the population has changed to whatever the new value is from 5422, because the did set would set the existing and put that value in that old population bucket. Right, brother? You feel me? That makes sense, and I like it a lot. I'll probably forget it by tomorrow, but that makes sense to me, brother. The syntax for property observers looks similar to computed properties, getters, and setters, but with different keywords. It does. The did set observer gives you a handle on the property's old value. Nice. So, okay. Yeah. So just by virtue of it being there, it's using that self argument again, right? The instance. Yeah. You create it. I know the property. In the example above, you create a custom parameter name for the old population. If you had not specified a new name, Swift would have given you the parameter old value automatically. So last time we learned that that's basically just an implementation of whatever, like in this case, did set. On the other side, it was get, right? But if you were to go look at the implementation for those, we would see a default parameter name in the way that we did it like 2 chapters ago when we saw that. But so that's just part of the language, just something to know. It's just something to know. That's where it's coming from. That was basically the whole answer for the last chapter. But it makes sense. I mean, and you can see what it's doing. It's just, yeah. The will set observer gives you, the response to the change is defined within the braces. Yep. This property observer logs the town's population information to the console every time it changes. Let's see what it does. Building it, brother. Success. What did it say? The population. Monsters tearing tails of victim pool population has changed from 500, bottom right hand corner, 1 million, whatever that number is. Yeah, okay. Okay. Let's change from population change from change from 1 million to, okay, yeah, we got those. The property observer logs the town's population information to the console every time it changes. So you should see a log for the population change after Fred the zombie terrorizes the town. Run the program and take a look at the console. It should look like the output shown below, with a log for every time the population changes. Oh, okay, I see. The population change from that to that, and then I guess Frank the zombie is unleashed. Changes again. It has changed. 54, 22, wait, 5, 4. How did it gain 10 people? 1, 0, 0, 5, 4, 1, 2. 5, 4, 2, 2. Weird. And then change to 500 from, damn, he went crazy. Super zombie. Okay. Because you are logging changes to population with a property observer, you no longer need to log the population change in main Swift after you update the victim pool. Remove the code from the call to print at the bottom of main Swift. Okay, so main Swift, we have something, there it is right there. Get rid of it. Population for the zombie. Oh, just that portion. I see. Okay. What? It's still the same. I don't know. Nobody got time to figure it out. Note that if you define a did set property observer on a lazy property. Oh yes, the lazy eval, which we learned about. So it wouldn't compute the value if it's lazy. Well, it won't compute the value when you initialize. Only when it's first read. So you're just kind of pushing off the work until the first time you need it, and then it's just there. And then after you need it again and again and again, provided it's the same, working session of your application, you would not need to run it again. But it also will not update again. So it's not a computed property. It's a one-time thing. So type properties. Dang it, I gotta go use the restroom real quick. Don't worry though, this is not a big deal. Fear not. I'll be quick. Oh shit. Oh fuck. Ba ba. God damn. God damn. Okay. Bum 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 bum. Adding store property. Type properties. Up to now, you've been working with instance properties. Oops, sorry. Hopefully that didn't make it stutter. Up to now, you've been working with instance properties. When you create a new instance of a type, that instance gets its own properties that are distinct from other instances of that type. When you create a new instance of a type, Oh, I skipped a sentence. When you create a new instance of a type, that instance gets its own properties that are distinct from other instances of that type. I see. Okay. Okay. Instance properties are useful for storing and computing values on an instance of a type. Okay. However, when you need to store a value that is common to all instances of a type, it is wasteful to store a copy of that value in memory for every instance. I see. So it's kind of like a state machine, like that's where you would store, well, at least in web dev, like that's where you would store all your common properties, and they can all just kind of look there. They can just have a reference to it because you know it's not going to change. And the only things in memory would be like your computed properties, dynamic properties. I feel you. Okay. So many terms though. Because Go also had this, but it seems, I don't know, I just can't stop moving my hand. All right, forget it. However, when you need to store a value that is common to all instances of a type, it is wasteful to store a copy of that value in memory for every instance. Yeah, it's hard to argue that one, brother. Instead, such properties can exist once on the type itself and are called type properties. For example, give me an example. For example, all instances of a square type will have exactly 4 sides. Okay, that's a good example. Yeah. So the number of sides for square might be stored in a type property. If you create 1,000 instances of square in your program, a type property for a square's number of sides will, why do I have the hiccups? Number of sides will only exist in memory, once in memory, rather than 1,000 times. Okay, well, when you put it that way, brother, it's hard to argue. Okay, so yeah, we can see the value. That's clear. Clear value, clear logic, clear reason for existing. Okay, so value type, structures, and enumerations. Man, I need you know what I need is I'm sure there are others, but O'Reilly makes, I have a number of them and they're very handy. Those little, they're probably, I don't have one nearby. Little reference books. They're probably as tall as the mic. They're little. And it's like literally just, let and print. And I guess I'm back from the toilet. It just gives you all the keywords basically. So if you were to go to like learnxandY.com, it's like basically that, but a little more information than that. More than a web page, but not a full-blown book. So yeah, that would be handy for Swift because god damn, there's just so many types of types even. They got types of types, type property, type value, get set, did set, dip set, you know what I mean? There's a lot of it going on. Shucks. At least we don't have to write classes though. As with type methods, type properties on value types begin with the static keyword. I actually like that. That makes it That's perfect. Yeah, static. Great. For this version of your program, all towns will exist in the same world. Declare a static property on town to hold this information. Yeah, you got it, brother. Struct town, which is in town, makes sense. Struct town, static, let world equal. Oh, I see. Okay, good. Well, at least it's staying inside the... I mean, it's not so bad if... it's a lot. It's still a lot. I can't really... But since there is a lot, you can do a lot. It goes both ways. Stored type properties have to be given a default value. Vale. So when they say default value, we're talking about this right here. So I guess it still is the assignment operator, but it's different than just a variable because of the preceding keywords here. So we're saying this is a type property, and we must give it a default value, which just looks like so. And like these are also default values in this case, because you can just have it like this. You don't have to have a default value. Okay, so then, okay, all right, I'm with it. Here, world is given the value Earth. Okay. Classes can also have stored and computed type properties, which use the same static syntax as structs. Pardon me, brother. Let's see. Subclasses cannot override a type property from their superclass. Huh? Subclasses cannot override a type property. Classes also have stored... I don't want to hear about classes, brother. Which stay... Subclasses cannot override a type property from their superclass. If you want a subclass to be able to provide its own implementation of the property, you use class keyword instead. You see why? Look, class. Oh, bro. I don't know why it bothers me so much, but it does. I really just don't care to know anything about... I mean, that's not true, but I don't want to use them, so I hate putting time against it, but it's all part of the example, so we must. Class func. Make spooky noise. Okay, so that's a... This is... Subclasses cannot override a type property from their superclass. If you want it. Oh, okay. So by itself, I couldn't do this. I see. I couldn't do that for a subclass. I don't know. I'm not going to act like that. Makes a lot of sense to me. I'm just not pleased even looking at it. All right. So then, and the return type is what? It returns a string. Return brains. Gosh. Okay. Notice that make spooky noise does not take any arguments. Here on line 11, make spooky noise. No arguments here. This makes it a great candidate for being a computed type property and not a method. Being a computed type property. Oh, I see, because there's no, you don't need any inputs. Okay, yeah. But we're still not using classes. Open Zombie Swift and add a computed type property for a zombie's catchphrase. Class var spooky noise. Hey, brother. Class calls class var spooky noise of type string return brains. Tormented. Okay. The definition of a type level computed property is very similar to the definition of a type method. The definition of a type level computed property, which is this, the class var spooky noise string return brains. The definition of a type level computed property is very similar to the definition of a type method. The main differences are that you use the var keyword rather than func, and you do not use the parentheses. Yeah. Okay. One new aspect of the code above is that you use a shorthand getter syntax. If you are not providing a setter for a computed property, you can omit the get block of the computed property's definition and simply return the computed value as needed. Switch to main Swift, add a line. Oh, right, yeah, okay, because normally you would wrap it if we were being explicit on the other one. Okay. Switch to main Swift, add a line at the bottom. Add a line at the bottom of the file to print the zombies, zombie types spooky noise property to the console. Oh, wait, that's not. There it is. Print zombie dot notation spooky noise. Not make spooky noise, spooky noise. Run the program, spooky. Brains. It said brains. Cool. To see that class type properties can be overridden by subclasses, add a spooky noise computed type property to monster. To see that class type properties can be overridden by subclasses. I see. Okay, so just we're putting on display that which we just learned. Class monster, class. Oh, okay. If this is a var, oops. If that's a var. What, brother? Class monster. Oh, I guess they usually show the markout, but that must be the same spot. Okay. Class var spooky string return grr. You may notice that the toolbar is indicating that there is a compiler error with a small red octagonal icon. If you do not see the icon, try running the program. Oh, I see it, brother. Oh, yeah, I see it. Switch back to zombie.swift. Okay. Switch back to zombie.swift, and you will see the same error icon on the line that begins the definition of spooky noise. It usually does show me in the line, but whatever. I'll take their word for it because I do see the error up here. If you click the red exclamation mark on the left-hand side of the edit area, the error will display. Overriding declaration requires an override keyword. Oh, just like right, yeah. So there. Oh no, it would be in the other one, the non-generic. Okay. And the error will display 16.2 overriding. Wait, class stored properties are not supported in classes. Did you mean static? I'm not sure what I meant. Override. There's only one. Oh shit, my bad. It's like, no, wait. This is class monster, spooky noise string, return gur. So that's, oh, I got this, yeah, okay, I got that. That's what I did wrong. Hot dog. Okay. And so did I do that in the right spot here? Class zombie in zombie Swift. What did I do? Class var. Okay, now I got it. Yeah, okay. That's what they're saying I should see in class zombie, and I do. Cool. Okay. Zombie is now overriding a computed type property from its superclass. Because you use the class keyword for this type property, it is perfectly fine for subclasses to provide their own definition of spooky noise. Gotcha. So it's a subclass because it's of type monster, and type monster has spooky noise already, which is gur. But we want zombie to say brains. And if we do class var, and since the original type had a class var, then it can be overridden by a subclass, except we need to put the override keyword in here. Class override var. Okay, so it goes after. Okay. Right on, brother. Zombie is now overriding a computed type property from its superclass. Because you use the class keyword for this type property, it is perfectly fine for subclasses to provide their own definition of spooky noise. You just need to add the keyword override to zombie's definition of spooky noise. Make this change and the compiler error disappears. Override class var. Class zombie monster. Wait, does it run both ways? Because this is how Xcode put it, and they got it the other way around. Override class var. Or does it not matter? Oh, why would it not? Okay. You just do anything. Any arrangement works. I get it. Build and run your program. Everything should work anywhere. We mentioned that classes can have static properties at the type level. Yeah. These properties work a bit differently than class properties on a type. A defining characteristic of all monsters is that they are terrifying. Add a static property to the monster class to represent this fact. Man. Yeah. Just. Yep, I don't know. This feels like, you know, working on classes when you know you have zero intention of using them and you know that you don't have to use them is like taking your bike to work and you have a perfectly functional car. You know what I mean? Like you get a quarter of the way there and it's already hot. It's like 8 a.m. You're sweating through your clothes. And you're like, why the fuck did I want to do this? That's the feeling I'm getting. I'm just saying. Just saying. But still, we persevere. Because you never know. Terrifying. At least, if nothing else, we can say, hey, we looked at it and we didn't like it. But we gave it a chance. and I think that's all anyone can ever really ask for, is a solid chance. You add a new static property on monster, represent the fact that all monsters are terrifying by definition. Because you added this property to zombie superclass, monster, right? Monster here, or here. It is also available on zombie. Yeah. Add the following to main Swift to see this in action. Right, so again, class, monster. And then when we make a zombie, we give it a type monster. So it inherits all this, all the properties, including that it's terrifying. And so you want me to do what? Go to main Swift. Go to main Swift. Where'd it go? Oh. Print zombie spooky noise. Spooky noise if zombie is terrifying. Print. Run away. Y'all ever play Worms? Any of the Worms games? Man, those were... I love Worms. Probably my favorite was... there was one on... I think it was... Worms Armageddon. If you like strategy games, it's turn-based, but it's not like a over the... like a bird's eye view, like a... what's... StarCraft style. It's not like that. It's more two-dimensional. So you see the entire landscape, and you're like... you're worms, like literal worms. And the idea of the game... this is one of the few games, by the way, you can play against other people. I'm sure plenty of people still play it, but you can it's also fun to just play, single player, which is hard. It's hard to find. But anyway, so you're a team of worms fighting against other worms, and there's these different levels, and the environments are fully destructible, and you just take turns shooting all kinds of weaponry at the other worms on the map. And so you can like throw grenades. It takes a lot of skill. It's really fun though. There's bazookas, grenades, you can throw stick dynamite. My favorite is the holy hand grenade. It's like this big giant golden grenade with the big cross on it. You chunk that shit over and it's like hallelujah, and then boom, and then it blows up like a quarter of the map. And anybody nearby just fucking sends them flying. Or my favorite, like the worms, as a worm, you as a being with no limbs, you're unable to swim. And so there's this concept on every map of there's a concept of falling off. Like you either fallen into the water, and it's like your little worms have names, you can name them. And so it's like little worm 2 took the big drink. And he just it shows him like slowly sinking, and he's like gasping for air. Play Worms. You owe it to yourself, okay? It's a cool game to just relax. It's a lot of fun. But yeah, anyway, the best one, I'll tell you about one more. All right, okay, 2 more. There's certain weapons are just drops, like you get them as like drop-in crates, and part of the, like each turn that you get is timed, so you only have but so much time to get into position, take your shot, or go grab a crate that falls, to get weapon drops, stuff like that. And so by default, you get a couple of weapons. You get regular grenades, you get a bazooka, and there's like wind, so you have to account for the wind. It's a really good game, but one of the default weapons you get is a little prod, just like a finger. So like if you're near somebody and they happen to be, like right by the ledge, it's humiliating and also hilarious to kill or be killed by the prod, because it does 0 damage. All it does is push the little worm. But if you're like 2 feet from the ledge, and I know that the prod is going to send you like 5 feet, I'm going to go embarrass you. So I'm going to drop down, and it shows him like inching over to the little worm. And then he's like, the little worm falls off the cliff. No. Man, it's a great game. Oh yeah, and then so there's another one. I don't even know what it's called. but it just has, it's like a little Japanese looking headband like the martial artists wear. And so kind of like the prod, but it has a little more range, and you can shoot like a little Hadouken, and he literally says Hadouken. So you like put on the little headband and looking like a Ryu from, is that his name? Ryu from Street Fighter. And then he's like Hadouken, and then he sends a little worm off. It's hilarious, man. There's a donkey, I think it's called the Concrete Donkey. No. I'm not sure if that was that game. I think it was. There's so many. Just go play it, all right? Now, there was a 3D version on Xbox, I think. Don't play that one. That never happened. But any of the other Worms Armageddon, I'm pretty sure it's on iOS. Get that one. That one's like a faithful port or a remake. Did I waste enough time to get over the hour? Almost 54 minutes. God damn it. Okay, let's see if run away. Yeah. Oh yeah, we're gonna try to. Okay, let's see if that runs first. Run away. There it is, right there. Bam, we did it. We can program. As you can see, you access the is terrifying property on the zombie via .syntax. Oh, right. That's what they wanted to show us. So we're in main Swift. As we know in the main file, main.swift, if you've worked with other languages like JavaScript or even Go is this way. Matter of fact, any of the Elixir was this way. I'm sure there might be other languages that do this. This is the first one I've encountered that does this auto import kind of thing, meaning you see at the top here where we import the foundation library, right? In Go, if you were writing other source files like this, like if I needed functionality from town.swift, this would just be another source file in the directory, right? Well, the main Swift is your entry point, and so you would import, town or some function from town that you're exporting, something like that. But in Swift, it just is aware. It just, you don't have to do that. There's no concept of importing within a given project. It just is aware. And so it's showing us here that since we made that change to the monster parent class here, it's static type property, and because zombie is assigned the monster type, then without doing any importing whatever here, we were able to write against the subclass the dot notation is terrifying, which is the type property on the parent class, which is made available. Bam, look at that shit. All in 1 hour. Fantastic job, self. And you guys for following along. Now, I'm going to boogie. I'm going to go, I have this thing I do before an interview. Play the Rocky music. Ding, 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 ding. All that shit, I'm going to go get hype. I'm going to, because I'm thinking about it right now, I'm going to get my, I don't think I'm going to have to show my screen, but I might to the interview. I mean, I really doubt it. It's rare that they ask you to actually code, go figure. But, yeah, I'm going to get that set up so I can record it and hopefully share that with you guys. Yeah. Anyway. Wish me skill, wish me poise, wish me articulation. Don't wish me luck. Luck ain't got nothing to do with it, right? It's skill or be killed here on this channel. Now, thank you guys for watching. I want all of you to have a wonderful day. I want you all to go in peace and go and do one thing today. Do it for me. Do it for you. Do it for somebody. I want you to do one thing today that you ain't never done before. One thing. Now here's the caveat. It needs to be one thing that you're uncomfortable with. Go talk to a girl. Go talk to a boy. Go talk to that dog you're scared of down the street that you're not sure if it's friendly. It could just be he really wants to play and you'd really like to meet the dog, but you're afraid. Just do something. Challenge yourself. And I'll do the same. And then we'll all meet back up tomorrow to talk about it. Okay, great. I don't know you guys, but I love you guys. We'll be back at the same time tomorrow. And make sure you tune in. Look on the screen right now. If you're following on X, it'll be on X at the same account, same handle. If you... Oh, wait, I don't got my gaming channel up here. Bro, okay. You know what? Just follow me on X. How about that? I'm not even... Twitch is just... I don't know. But it doesn't matter. Tune in tonight and every night, 9 p.m. Central Time for 2 hours, 3 hours. If you're into Halo, or if you're into me, or if you're just into background noise. For any of those reasons, brother, make sure you show up and watch. I appreciate y'all. Love one another. Be kind.